Okay, welcome to Group 3, Unit 2 program exercise. We're going to go over a decision-making problem that is based out of goal programming. And what it means is that instead of having just one minimization or maximization target, there is different targets or different goals that are weighted differently by the in this case the customer, Priceler, and each one has a different weight. And what it does, it allows us to do a cost benefit analysis pretty much in the optimization, where we look at what is the impact of not reaching some of those goals, and how can you provide a solution on the LP that will target the highly weighted solutions or goals, and will favor them. So in this case, the customer is Leon Burnett Advertising. Actually, the customer is Priceler Auto Company. So the customer is Priceler, and Priceler has hired a advertising company that's called Leon Burnett. Leon Burnett. Okay. So what they're doing right now is there's three different goals that the customer has on their advertising, and the two mediums of advertising are the football games and the soap operas ads. So, and they're given by a table that we're going to review. So in this case, to begin with, there is a couple of goals. We're going to write the goals out. So the first goal, so goal number one, so let me put here goals. Goal number one is that these ads should be seen at least by 40 million high income men. And these high income men, I'm going to call them HIM. Goal number two is that these ads need to be seen at least by 60 million low income people in general. And the third goal is that the ads should be seen at least by 35 million high income women, which I am going to call HIW. So these are the main three goals right now. I'm gonna put them in blue right here. I'm trying to see if I can fit everything in one shot in the screen. So understanding this, with Lil Burnett, they have to purchase two types, right? We said one was gonna be TV, one was gonna be in the football ads, and the other one was gonna be in the soap operas. Now, there is a restriction on how much they can spend. So the most they can spend on ads is $600,000 on ads, and that's kind of like what the most they can spend on the ads. We have a table 52, which kind of dictates how much each minute costs in millions for football and soap opera. So I guess we can determine that right now. It is given by the following table, right? So we have in millions, we say we have football. So I'm gonna put it here, football. And we also have soap operas. I'm gonna call it like this, right? And then we have the three with the hem, the lip, and the high income woman. So what I'm gonna put it, I'm trying to fit everything here like this. Gonna come back here and put him, lip, HIW, and then the cost in dollars. So this means that millions of viewers, so 7 million. So in football, it's going to be 7, 3 in the soap operas. This is the cost and number of viewers, right? So the number of viewers, 7 in football for the high income male, and 3 for the in the soap operas for the high income male. And then on the lip, you have 10 and 5, and then you have 5 and 4, and then the cost is $100,000, $100,000 for football, and then 60,000 for the Zobra, right? Okay, so that's kind of where we're at right now. So our initial formulation right now, basic, what we want to do is we want to identify with the decision variables. So we're gonna start calling these. So our initial statement is gonna be X1 is the number of minutes of ads shown during football games. So number of minutes of ads in football and during football games. During football. And then X2 is what we're going to call the same number of minutes of ads during soap operas. Okay, so at this point we have our decision variables, and then basically what we want to do is at this point we want to minimize or maximize these goals, right? So we have a very basic objective function at this point. And the objective function in this case is going to read something like, you know, you're going to minimize or maximize, depending, really. And then it's gonna be the, oh yeah, I lost it here for a second. Okay, so we were talking about the objective function. So we have a kind of placeholder, you know, we want to minimize or maximize the amount of minutes on so we add here, but you know, the amount of minutes or any other objective function for both of our decision variables, right? And then we have our subject to or constraints, and these are given by the table right here. And I'm gonna just state them now so that we have 7 of X1, 7 of X1, meaning of football, of minutes of ads during football, because we have the amount of viewers, 7 million, plus 3 of soap opera minutes. And this has to be at least, so it has to be greater or equal to 40 million. Meaning that in combination, all ads in football and soap opera and that's what represents the 703 has to be 40 million. And this constraint is what we're gonna call the him, which is on the table. You know, we also have then the lip, which is the low income people. And that's given by the table, 10 and 5 right there. So you are gonna have 10 of the ads in football added by 5 of the ads in soap opera, has to be at least 60 million, meaning equal or greater than 60 million. And then we do the same thing with the high income woman, right? We have the high income woman, and this one is given by the table 5 and 4, so 5x1 plus 4x2, and it's the same. It has to be greater than 35, as we stated here. At this point, we also have this budget, right, constraint, and the way we mark this right here is that 100. So 100 of the x1 and we have that state here. Okay, so we were talking about the last restriction there. So if we look at the cost, that 100K of the football plus the 60K of the soap operas cannot be greater, has to be less or equal to the 600,000 that we have, 600,000 that we have in the budget constraint. Now, and then we of course we have the non-negativity, that all our decision variables have to be greater or equal to 0. Now, the interesting part here is that if we look at these opportunity cost benefit opportunities, the problem also says that for each million, it analyzes that for each million. So what we're trying to do is we're trying to maximize the exposure of the return, right? Because so yeah, what I was trying to find here is that it does give you an indication of how much money does it lose this for every million that it falls short of every goal. For example, on the HIM, which is the high income male, for every million that it falls short on the goal, you know, for every 1 million, it loses $200,000. $200,000 is penalized. If we look at the low income personnel, for every million, it loses 100K. And for the high income woman, for every million, it uses, and I guess I can use a better designation here. For every million, per million it loses 50,000. So what it is, it's giving you a cost benefit analysis of, you know, now the goals, each goal is tied into an opportunity cost if you do not reach the goal. Now looking at this, then we want to transform this LP into what we would introduce some decision variables, because the decision variables is what's going to allow us to actually equate some of these goals to create the equations that we need and play with different surpluses and so on that will allow us to get as close as we can, as close as we can. So let me get this running. Okay, and so the trick here is, as I was saying before, is to find a way to transform these inequalities to equalities. And the way we do this is we introduce decision variables. In this case, we want to introduce a decision variable that's going to allow us to calculate if we go beyond or under the goal. And some of these, and I'm going to introduce these, and we're going to give them a designation of SI on the plus side and SI on the negative side. Meaning the plus is going to be the ones that tell us how much we exceed. I want to make sure I write this right. Exceed goal. And then this one's going to tell us how much this I goal we fall under, by how much we fall under the goal. So if we do that, then what's going to happen, and then I'm going to delete this from here right now, because then what we're going to be doing is we're going to be transforming these into a new standard format. So I'm going to make a line here and introducing these new decision variables. What we're going to be doing is we're going to be having. I'm just going to lay it all out, because then what we're going to do here is we're going to understand now. We're going to introduce the opportunities. We're going to introduce these opportunities, meaning cost, opportunity cost, with these new decision variables. So our new LP objective function is going to look something like, we're going to minimize this cost opportunity, right? So we're going to minimize it, and we're going to introduce that. So it's going to be a 200 S1 to S1, and for how much we want to minimize how much we're actually being under, because every time we're under, we're letting, for every time that we're under 1 million, we lose that opportunity. So for everyone. So, and then we're going to add the 100 S2, and we're going to add the 50 opportunity, 50 for S3, right? Okay, and then we have our new constraint sets, which are going to look very similar to what we had before, but we're now adding these decision variables. So we're going to have a S1. We got them all now. 7x1 plus 3x2, and then we add that decision variable if we go under, and then we subtract the surplus one, and this needs to be, and now we can make this equal to 40, which is the high income males. We come back again here with the second, which is the one that has for the LIP. So again, this is going to be him, LIP, and then the woman, high income woman. So this one is going to be for the low income people. So it's 10x1 plus 5x2, which is what we had already, but now we add the decision variables, we subtract the surplus one, and this needs to be at 60, equal to 60. And then on the high income woman, as we said, we go back to that 5 x1 plus 4 x2, and we add the surpluses and unders and surplus goal. And this needs to be 35, equal to 35. Okay, so now we have our new subject. Now we need to add also the budget constraint one, which we had it there. It's the one with the 600. That one really won't change. It's gonna be x1 plus 60 x2, and it needs to be under 600. And then we have all the non-negativity, excuse my writing there, non-negativity variables, meaning all of these variables are equal or greater than 0. Okay, so far what we've done really is converting our basic linear program formulation to a stand form where we introduce the decision variables. But now the actual preemptive goal programming is really based on prioritizing your goals. And here we can see that the cost benefit of the opportunity cost of losing high income males per 1 million it's twice the one for low income price and 4 times the one for high income women, meaning that it has a major weight. So in reality, what we're going to call these, this is going to be priority 1, this is going to be priority 2, and this is going to be priority 3. And what this does right now, really, it gives us a new objective function, really, or transformed by a priority objective function, which looks something like we're going to minimize the impact, and it's going to look something like priority 1 and S1 plus priority 2 S2 under, and priority 3 S3 under, meaning what this is going to tell us is we're going to minimize the impact for each one of the types of ads and population that we're tackling. Under, we're going to minimize the sum of all threes, prioritizing P1 over P2 and P2 over P3. And we would just add this new objective function, and it would be the same constraints at this point. Now, at this point, when we do this, and we use the simplex goal programming, now in difference of the regular format, now you have 3 zero rows, what you call, or basis rows. So now we're gonna have 3 of these, and we're gonna have row 0, right, which is goal 1, and this is gonna be row 0. We're gonna call it row. I'm gonna put the 1 here. I'm gonna put the second goal here. I'm gonna put the third goal here. But row 0 there, it's gonna be of the goal 1. It's gonna be Z1 minus the priority 1 as -1, and this needs to be equal. We're gonna equate these to 0. This is just 2 points here, or 2 points. And then there's another row 0, but it's goal 2, and it's gonna be Z2 minus P2 as -2, which also we're gonna equate it to 0. And then there is the other row 0, which is of the priority P3, and it's gonna be Z3 P3 as -3, and we're gonna equate that to 0. So let me make sure I'm getting some ink on this one. Okay. I'm gonna delete this. I'm gonna pause and delete for a second. Okay. So after that setup, we then start laying out our tableaus and start actually formulating, so finding the basic feasible solution or the most optimal solution through our Tableau and Simplex methodology. So at this point, and after everything that we did the layout, we have our initial Tableau or table, and it's gonna be something like this, where we're gonna have our basis, and then we're gonna have x1, x2, x1 negative, S2, I'm sorry, S1 positive, S2 positive, S3 positive, and then we're gonna have our S1 negative, S2 negative, S3 negative, and then we're going to have also our here, let me, and then we have our S4, regular S4, which comes out of the 600, and then we have our right hand side. We have our right hand side. So this is basically our table, and in our basis here we have, as we said, 3 0 rows. So we have our high income males, low income personnel, and high income women. These are all considered 0 rows or basic rows. And then we have our regular HIM, LIP, and HIW. And the last row, it's going to be our budget. So if we represent these, we're going to take them out of our objective function that we already work in our constraints. We're going to have, and then this one is based on the priority objective function or formulation. We're going to have 7P1. X2 is going to be 3 priority 1. We have a negative P1 here, and then we have 0 for all others. So it's going to be a 0 0 0 0 0, and the right hand side on this one is going to be a Z1 equals 40 P1, 40 priority 1. It comes from the million, the HIM, rows of 0. And then we continue, we go like that for the next row. This is going to be 10 P2, just coming from here, from the LIP, 5 P2, then we have a 0 on the S plus, but we have a negative P2 on S2. And then we have all zeros again. And this one comes from the constraint of 60 million, so Z2 is going to be equal to 60 P2, right? And then we move on with the next row, which is 5 P3, 4 P3 under X2. Then we have 0 here, 0 here, and then we have a negative P3 on this side under S plus 3. And then we have again zeros, 0 0 0 0, and then this is Z3 equals to the 35 million priority of 3 P3. Okay, so now that we go to the regular constraints, The first part lays out the priority ones, and then now we just go to the regular ones, which is A7, 3, -1, 0 here, 0 here, and then you have a 1 under S1. So the SS1, you have a negative on the S1, because this equates. And then we have 3 zeros here, and then these are just equal to 40. And then on the low income people, you have a 10, a 5, a 0, and then on the priority 2, you have a -1. Then you have 0 here, and then you have a 1 on the S2 negative priority, the priority 1, and then you have a couple zeros, and 0, 0, and then you equate that to 60. And then we have the high income women. So this goes to a 5, a 4, a 0, 0, -1, 0, 0, 1, and then a 0 here on the last one, and then you equate this to 35. Excuse my board here. Now, the budget constraint here, we know that for priority 1, 0 on the X1, 100, I'm sorry, and then the X2 is 600. This comes from the cost right here, the cost for each one. Let me make this a little more readable. 60, I'm sorry, and then it's zeros all across. But then you have a -1 in S4. A 1 in S4, and then you equate this to 1, and then you equate this to 600. Okay, so this is our initial tableau. There's a couple more operations that we're going to do, but in this case, we look at the entry level, the pivot with the best ratio, and we have a basic feasible solution here, which is the 40, 60, 35, and 600, because in reality, Z1 at the priority 1, this goal is not satisfied yet. So what we want to do is we want to get we have the most positive in X1, and the ratio indicates that the X1 should enter the basis. So X1 should be the one entering the basis for ratio wise. 600 divided by 100 is 6, but then if we do a 40 divided by 7, it gives you the highest ratio, which would become to about almost 5 something, 6. I'm sorry. Let me rephrase that. Okay, so in this case, we're gonna base by applying the ratio in the row hem, and the most positive is number 7, so we're gonna pivot on number 7 right here. So if we pivot on number 7, we're gonna have a transformation there, where after that we're gonna have a different tableau, a totally different tableau table, and then we're gonna have to pivot S1 plus. So the final tableau, I'm gonna let me do for purposes, I'm gonna stop and pause. So after the 2 transformations, we're gonna have the following table, which we end up with him only here on the X1, and that's what's going to allow us to get to the most optimal solution on X2 as well. We have a 0. Negative P2, P3, 3/5, -1, 1, and 6/5. Under the S1 plus, we have everything zeros here, but the last one. There's 1 here. The S2, we have 0, negative P2. Let me see if this one works better for now. Okay, this one seems to be working better. Then we have a 0, a 0, a -1, and a 0, and a 0. We end up here with 0, 0, negative P3, as we expected, 0, 0, -1, 0, as you can see, so coming down. Oh, okay, yes. Under the S1 negative, then we came with a negative P1. Then we have a negative 10 P2 over 7, negative 10 P2 over 7. And then we have a negative, and this is actually, yeah, 5 P2 as well over 7. Then we have a 1/7 here under the him row. Negative 10 over 7. Negative 5 over 7, and then we have a no, my bad. This transformation was not. This transformation. Let me rewrite this again, because after the second transformation, all these went down to 0, 0, 0, 0, 0, and -1. That's what it was expected. Under S2 negative, we have all these zeros. And then on the low income is where we have a 1 and 0, 0, and then it starts coming up. Now, and then under the S3, we have a 1 here, and then we got a 0, 0, 0, 0, 0, 1, 0 up there. And then here's where we start having some nonsense of big numbers. So we have a negative P2 over 10, negative P2 over 20, 1 over 100, negative 1 over 10, negative 1 over 20, and the last row of the budget, we have a 7 over 10, over 100, I mean. So describing the right-hand side at this point, we have Z1 equals 0, Z2 equals 0, Z3 equals 5P3, and then we have, for basic physical solutions, we have a 6, a 0, a 5, and a 2. Now, with this last, we see how the first goal and second goal are met, but where we have our basic feasible solution of 6, 0, 5, and 2. We try to come closer to goal 3. It's going to, meaning this one right here, it's going to become, we couldn't do it without violating one of the rules. Because it has a negative coefficient in row 0 for the goal 2, so that one's good. Variable positive coefficient in row 0. So yeah, so it would be violating a high priority goal. So therefore, this is what it would come down to, our basic feasible solution at this point. I think I can leave it as that. So what I'm gonna do is I'm gonna write so what you see here is our basic feasible solutions. We have 3 per priority. Priority 0, priority 2. So 5P3 is for priority 3. We managed to get those exact. So our BFS at this point would become x1 equal to 6, which is this one. We would have s negative 2 equal to 0, s negative 3 equal to 5, and s positive 1 equals to 2. And this actually is our basic feasible solution for this side right now. I believe that's all. So